All right, so I think this is recording. Let's take a look at these three problems. They want us to find the domain and range. Remember, the domain is the set of all real numbers, excluding any, any values that cause division by zero, and also excluding any values that would cause us to take the square root of a negative number or the even root of a negative number. So let's take a look at number 9. We do not have any variables in a denominator. However, we do have a variable underneath an even root, this fourth root. We can't take the fourth root of negative values. So this number that's underneath the radical, this expression 8 minus x, has to represent a real number that's greater than or equal to 0. If we add x to each side, 8 has to be greater than or equal to x. I like to write my variables on the left-hand side. The arrow is pointing towards the x. It's still pointing towards the x. On a number line, if I have 7, 8, 9, I include this endpoint 8 because it's underlined there, and values that are less than 8 are to the left. So here is a graph of my solutions, or excuse me, of the domain, and written in interval notation, the domain is from negative infinity up to 8, including 8. Now, what about the range? Well, we're going to go to a graph, but you will see in a later skill packet that we'll be able to sketch the graph of things like this. There is a shift to the left and a reflection and another reflection, but you know that's getting ahead of the game a little bit. We'll go. I'll find the domain of 10, find the domain of 11, and then we'll come in and look at the graphs to find these ranges. All right, so let's take a look at number 10. I don't have any radicals this time, so I don't have to worry about taking the square root or even root of a negative number, but I do have a variable in a denominator. This 6x minus 3, if it were to equal 0, we want to exclude that value of x from the domain. So if we add 3 to each side and divide by 6, 3 divided by 6 reduces to 1/2. So the domain is the set of all real numbers, excluding 1/2. Here's where 1/2 is. It's the only number that satisfies this equation. It's the only number that causes us division by 0. It's the only number that we exclude from the domain. So the domain is all real numbers from negative infinity up to 1/2, excluding 1/2, and from 1/2 to positive infinity. When we look here, we have a radical, but it's different than number 9. In number 9, the index was an even number, 4. Here in number 11, the index is odd. When it's odd, the domain is all real numbers. All right, so let's go and take a look at the graphs of each of these to find the range. So in number 9, this fourth root, because of this negative sign there, I believe that the graph is going to indicate that the range is from negative infinity up to 0, but I'm not totally positive about that, so let's go and check. Yes, this graph is below the x-axis. That's where the negative y values lie, and it goes all the way up, and it does touch the x-axis. 8, 0 is a point on the graph, so 0 is in the range. So our range, the range of this function for number 9 is from negative infinity up to 0 and including 0. What about for number 10? So here we have the range is a set of all real numbers except for, it looks like, y equals 2/3. You see that horizontal line? The graph gets closer and closer and closer to it, but it never touches it. Now, how can I convince you to see that easily? In a later skill packet, it'll become much more obvious. As you move far away from the origin, as x gets really, really big, this -3 plays little consequence. So as you move away from the origin, this becomes more and more like 4x over 6x, which reduces to 2/3. So, but it'll never quite get there because of this -3. So the range is the set of all real numbers excluding this 2/3. And that is apparent from the graph here. You can see that the graph curves in and it's getting closer and closer to that line, but it never touches it. All right, so what about the range for this number 11? Well, with it being a cube root, the range is also going to be all real numbers, and that's going to be true of any odd root here. Even the negative sign out there isn't going to affect it. It's going to affect the appearance of the graph, but it's not going to affect the range. So I'm expecting both the domain and range to be all real numbers. Let's go and look at it. Yeah, this graph is going up. It's not going up very quickly. It's not very steep, but it's going up forever here. It's going down forever here. So up and down is from -infinity to +infinity. There's no holes. There's no jumps in the graph like we've seen in some of the other graphs. All right, so like I say, that the range is going to be a difficult concept. You're going to have to gain some experience by looking at the graphs. So don't be worried if you're finding the range more difficult to find, because that's normal. When we get into later skill packets and really begin to look at some of the shapes of some of these well-known functions, it'll become a little bit easier. All right, so I hope that helps, and I'll talk to you later. Bye.